Hello everyone, and welcome to the video for section 3.3 where we're talking about polynomial division. And before we get into what's going on with this notation that we see over here and basically the definition of what polynomial division is all about, I want to go back and remember what's going on with division just with numbers. Now, whenever we divide numbers, for example 9 divided by 2, something like this, we're asking the question, especially whenever we're not treating this as a fraction, but we're treating it as this operation 9 divided by 2, and we're expecting to get a remainder, or we are going to go ahead and carry out this kind of a long division process. We're looking to get a number up here that is called the quotient, and then we're going to do some different arithmetic, and then we will end up with a number at the very end, which we are going to call the remainder. Now, what the quotient and the remainder are talking about, the quotient is how many times the divisor, which of course this number is the divisor. We have the number that you are actually dividing is called the dividend. And then whatever answer you get for this one is called the quotient, but actually we will have a quotient plus a remainder. And in this case, if we actually are writing this one where we have a division that looks like a fraction, we should put the remainder over the same divisor like this one. And so we would get, just as an example, this one, 9. This, since it looks like a fraction, I'm going to use words like fractions are. So 9/2, we're able to write it as 4 and then plus a half. We can do it that way. And you can confirm if you go ahead and do the long division, we'd say that 2 goes into 9 4 times. That's the point of the quotient, is it's how many times the divisor will go into the dividend as a whole number, how many whole times it will go in there. And then we need to multiply these and figure out, okay, it went into there 4 times, so how much is going to be left over? And so we say, well, after 2 goes into 9 4 times, that basically is 8. And so we subtract them, we say there's 1 left over. So we'd say 4 with a remainder of 1. Now, this is what's going on with numbers. And it seems maybe kind of odd, and it would be a lot more difficult, a lot more involved to actually prove this fact that it's possible to do this same process using polynomials. And that's the point for this section, is that we're going to talk about how to divide polynomials, especially using things like long division, and then there's something else called synthetic division that we will see. But we're going to go through this process, and what we have, by the way, I'm going to write a different form for this one. Instead of saying 9/2 is 4 plus a half, it's also worthwhile to write this other form, which would say that 9, we can write it, since we're interested in dividing it by 2, that's what we're doing in this example over here, we can write it as some multiple of 2, which we found out that the quotient's actually 4, so it's 4 times 2, and then it's going to be plus that remainder of 1. And so we're able to do the same thing with polynomials, where here we see this first form of a polynomial. If we want to divide f of x by something, which here we call it d of x because that's the divisor, we've got the quotient goes q of x, and we have the remainder goes r of x. If we are wanting to divide f of x by d of x, really what we're looking for is how could f of x be written basically in this same way that we did with 9. It needs to be some multiple of the divisor, which here we had a multiple of 2 since the divisor was 2, it was 4 times 2. And so the divisor times the quotient, except for these will both be polynomials. We can write it as a product of these, and then there will be some amount of a polynomial that's left over that is going to be called the remainder. And it's especially useful to write it in this other form. That's why first I was writing this kind of a fraction-y form, because whenever we write down this form that we have right here, like f of x over d of x, this is actually the division that's going on, where it's f divided by the divisor that we're calling d of x. Once we have this one though, and this will be the subject of 3.5 where we're talking about rational functions, this over here, the same way that 9/2, it can either be interpreted as 9 divided by 2, or else it also looks like the fraction 9/2. This form that we have for dividing these polynomials, it looks like a polynomial division like f of x divided by d of x, but it also has the identical form to a rational function, where a rational function is just two polynomials, you know, a polynomial on top and a polynomial on bottom of a fraction. And so it can be very useful to think about how we would write this result using rational function type of a notation. And so that's what is the aim of this form, where we can write this as just some polynomial and then plus another rational function over here. The same way that whenever we basically simplified, or in fact we converted it basically to mixed numbers, this fraction of 9/2, we're able to write it as a whole number and then plus some fraction left over. It's kind of the same idea with polynomials, where a polynomial is kind of taking the place of a whole number. And whenever we divide these two polynomials, we can get a polynomial out of it and then plus some fraction that is a rational number. And this will be helpful, or I should say a rational function. And this is going to be helpful whenever we're going to try to graph one of these kinds of rational functions. We will actually graph them by doing this polynomial division. So that's why first we want to talk about how you would actually do it. Now, there's something called polynomial long division, and this will work for sure for any two polynomials. This will always be a way that you can divide them. What we're going to see later, synthetic division, it only works in special cases. So we will take a look at this long division, and we write it down. We set it up actually the same way that you would set up long division for numbers. We just write down what we have as the dividend, and we write down the divisor with this kind of a rooftop thing. And then we're going to start assembling this quotient over here by putting how many times this divisor will go into this dividend. And actually what we're looking at, the only thing that we have to consider are these leading terms. The fact that this one goes 2x and the fact that this one goes 2x cubed. And so actually the number that will go here is going to be what we get when we divide 2x cubed divided by 2x. And so if you think about it, 2x cubed divided by 2x, the 2's will cancel. Also we have 3 x's on top, like x cubed, and then we have x on bottom. So one of the x's will cancel. I will change it from x cubed into x squared. And you can see that it will go x squared times. And the point of this is that on this next step, we need the highest power term to be canceled out. And so we'll see whether it works or not. But what we need to do now is multiply the same way we would do with long division with numbers. We need to multiply this element by what we have as the divisor over here. So we're going to go x squared times both of these terms. So x squared times 2x is 2x cubed. And if we did not get the same thing here, see how they both go 2x cubed? If we somehow did not get the same thing, then there's a mistake. And we need to go back and pick the right number as the first part of the quotient over here. Because we're about to get ready to subtract everything that we get here from the line above. And so this first term needs to cancel for sure. But anyways, x squared times negative 5 will go minus 5x squared. And then now we're going to subtract this thing that we got. And so you could think of either just subtracting these terms individually, like doing 2x cubed and minus 2x cubed and getting 0. And then doing negative 11x squared minus negative 5x squared. So that's basically the same thing as plus 5x squared. Negative 11 plus 5 goes minus 6x squared. You can just subtract them like that, or you could go ahead and distribute this negative sign and then consider adding them. So what I'm doing is I'm distributing the negative, so it would become negative 2 here and then plus 5. And then you can go ahead and just do it. So when you add these, you'll get 0. When you add these other ones, then negative 11x squared and the 5x squared, you will get negative 6x squared. And then we're done with the first step. That's how the polynomial division is going to go. And then we're considering this thing as basically being the new leading term, because we already canceled the old one. And so what we would do is just bring down what's left over from the previous dividend. Just bring it down, these terms, just bring them straight down. And then we're just going to rinse and repeat. We'll do the same process. So we're wondering, how many times will 2x go into this thing? Negative 6x squared. So if you think about what you would get, negative 6x squared divided by 2x. One of the x's will cancel. It would just become x on top instead of x squared. And then 2 and 6, we could cancel a factor of 2 and make it be negative 3 on top. So it would become negative 3x. And that's what you should get. If you divide negative 6x squared by 2x, you will get negative 3x. And so that's what we put, minus 3x. And then we'll go through the same process. We will multiply. So negative 3x times these two terms. When it goes times the 2x, it will go minus 6x squared. And there again, since these two terms are the same, then we know that we did the right thing. And then it will go negative 3x times negative 5 goes plus 15x. And then we are done multiplying here, so we need to just subtract these. And here, maybe it makes sense to just go ahead and distribute this one. And so the negative times this negative will make a positive, and then when what was negative, it distributes inside of here, it will make minus 15x. And so it's not plus anymore, it's minus. And then we're going to add these. So negative 6 plus 6, it would become 0. And then 13x minus 15x becomes minus 2x. And then we're able to just bring down the last term that we have there, the plus 15. And then we're getting very close. This 2x is able to actually go into minus 2x. Think about what you'd get if you do minus 2x over 2x. That's what's going to go here in the quotient as the last item. So the x's will cancel. The 2's also would cancel, it leaves 1 up here, so we end up with minus 1. And then we need to do this last multiplication and find out what we have left over. So minus 1 times 2x will go negative 2x. This is the last time where we needed to multiply, and sure enough, we got the same first term, so that's going to cancel, so we picked the right element for the quotient there. And then we do negative 1 times negative 5, so it will go plus 5. And then we need to subtract this, and running a little bit out of room there. Need to subtract this one, and so the negative with the negative will make positive. I'm going to go positive, and then also negative with this one will go minus again. And then just adding these. Negative 2x plus 2x is 0. And then 15 minus 5 is 10. So we end up with a remainder of 10. We could write it. It seems a little bit clumsy, write remainder of 10. This is not really going to be our final answer, though. What we should write is that the answer for this division is x squared minus 3x minus 1. And then there's a remainder of 10, so we should write it as plus 10. Since it's positive 10, there's a plus here. If it was negative 10, we'd go minus whatever's here. And then over the divisor, this thing, 2x minus 5. And that's what we got by dividing them. It's almost like a process of simplifying, if you could call this simplifying, this fraction. It definitely makes the numerator of this fraction much easier to handle, having 10 on top rather than having this whole cubic expression like we had before. But anyway, this would be the way that we would want to write the answer for this one. And that does it for doing long division. It'll just take a little bit of practice to get this one down. I mean, the process, it's so similar to the same process for doing long division with numbers. I think that if you try a few examples, you'll realize how closely they're related. But anyways, in the next video, we'll start getting into synthetic division, which is I think much easier, much more convenient. But anyway, thank you guys for watching. I'll see you in the next one.